All right, so let's talk about where we've been, and then let's talk about where we're going. What we've done so far with quadratics is we've graphed quadratics, we've looked at vertex form, we've looked at factoring form of graphing. We have looked at patterns to determine whether a pattern is linear, quadratic, or exponential. So now what we're going to do is we're going to take these quadratics, we're going to say that we have this quadratic pattern, and we want to take a quadratic equation and solve it for x. Now, in order to do this, there's a couple things that need to be set up. And to be honest with you, we've actually laid the groundwork for this already. So this might sound a little familiar to you. When we take two numbers whose product is 0, one of them must be 0. 8 times 0 is equal to 0. Negative 19 times 0 is equal to 0. 0 times 14 fifths is equal to 0. What all these have in common is that in order for two numbers to be equal to 0, one of those numbers has to be 0. And this is known as the zero product property. And so what we say is, if A times B is equal to 0, then either A must equal 0 or B must equal 0. So you're going to hear this phrase, the zero product property, being used quite often. And we use that zero product property to solve quadratic equations for x. So this is a quadratic equation. You might not recognize it as a quadratic the way it's written right now, but it is in factored form, so you probably should recognize it. And I have x minus 6 times x plus 3 is equal to 0. And I want to know what are the values of x that make this equation true. Well, with the zero product property, it's very easy. I can simply say either x minus 6 must equal 0 or x plus 3 must equal 0. Therefore, my two solutions are going to be x equals 6 and x equals negative 3. I just solve each of these equations for x. And one that's a little bit different, we have this in standard form, x squared minus 13x plus 42. So what we're going to have to do, wait, where are you going? Why are you moving me? Oh, okay. I guess I have to move over here. In order for x squared minus 13x plus 42 to equal 0, what we're going to have to do is put this into factored form. Because the zero product property only works when we have two factors that are equal to 0. Okay, so if I factor this, this should bring back some good memories. X squared is x times x. 42, we have a lot of different options for 42, but we're going to say 7 and 6. And as long as both of these are negative, negative 7 and negative 6, then I know that, that the sum of negative 7 and negative 6 is going to be negative 13. Okay, so now I say x minus 7 is equal to 0 or x minus 6 is equal to 0. Therefore, x is equal to 7 or x is equal to 6. In other words, if I were to plug 7 back into this original equation, and you can try it right now on your calculator, 7 squared minus 13 times 7 plus 42, I'm going to get 0. But what's unique about this is there's actually two values of x I can plug in. I can plug in 6 also. 6 squared minus 13 times 6 plus 42 will also equal 0. Okay, so here's another one last factoring equation here. 2x squared plus 7x plus 3. This is a little bit different, maybe a little bit more challenging because I have a 2 out in front of the x squared. So if you remember from your days of factoring, we're going to set up our parentheses, and then I'm going to find two numbers that multiply to get 2x squared. So that's 1x and 2x. I'll place those in there, 1x, 2x. Then I'm going to find two numbers that multiply to get 3. Well, that's pretty easy, 1 and 3. So I'll place a 1 and a 3. Now, before I'm ready just to say, yep, that's factored, I got to check to make sure that my middle terms do end up giving me 7x. So 1 times 2x is 2x. 1x times 3 is 3x. The problem is that 3 and 2 do not combine to get 7. 3 and 2 combine to get 1. They can combine to get 5, or negative 5, or negative 1, but they don't combine to get 7. So let's try going ahead and switching out the 1 and the 3. Let's make it a 3 and a 1. Okay, so now I check my middle terms again. That gives me 6x. My outside terms gives me 1x, and sure enough, 6x plus 1x gives me 7x. So now I'm ready to put in the plus signs. I'll set it equal to 0, and now I have this thing factored. Okay, so now that it's factored, now I'm going to go ahead and use the zero product property. And I'm going to say 1x plus 3 equals 0, or I can say 2x plus 1 equals 0, and here I get x equals negative 3, and here I get x equals negative 1/2. So these are the two values that when I plug them in for x, they make the equation true. And that's how you solve a quadratic by factoring.